So I'll talk into the microphone so everyone can hear. So Devconnect just had this great explanation of the theoretical part about tank sharding. But then comes the more like implementation-focused part, where all these samples do require lots and lots of network communication. And so our goal here is to try around two problems. We have, what do we want to optimize for? Bandwidth. Actually, think of another one. Bandwidth, we have latency, and we have altruism. This is a problem widespread in the network layer, where lots of things in network layer are not really attributable on-chain, but we do want people to serve and participate as a honest actor. And so the way we currently approach this is with peer scoring. And peer scoring only really works with like frequent communication and smaller meshes, whereas sampling is this thing that distributes randomly across the whole network. So it's difficult to put a score on a pair that you don't talk to with afterwards. And so there are two design directions so far, where we could either try and implement this sampling thing on top of LibP2P, which is a TCP-based solution, so we have persistent connections, like a set amount of pairs, or we have DiskV5, which is our current discovery protocol, which is built on top of UDP, which is communicating infrequently with many more pairs. So in this way, it's more similar to sampling. At the same time, it's a DHT. It's very different than gossip sub, and so it may have latency problems. And then when we think of and attackability, right? So in peer-to-peer networking in general, you can try and fake an identity or try and like have multiple identities as a single pair, Sybil attacks. So we want to try and avoid this from harming the distribution of samples. We don't want anyone to spam the network with Sybil identities to then basically have the one say about what's being served and what's not being served, and worse, to deterministically, selectively hand out samples to those that request it, because that might prevent people from sampling correctly. So one attribute here, where sampling is supposed to be random, it's supposed to be something that the pair that is trying to verify for themselves if this sufficient amount of data is available, they pick the samples themselves. It's not selected by the protocol. If it is globally selected, we don't have, it's not sufficient to replicate it n times, so everyone will be doing the same thing, and it will be very predictable for an attacker to try and influence. And so what we also kind of want to preserve is this ability of nodes on the network to decide for themselves which samples to request. And as you may have guessed, this is a huge problem in networking, because it means that you have to traverse the network, find pairs that are able to serve you those random samples. If you think about the LibP2P design with TCP connections, then we have more persistent connections, more persistent pairs. So we either drop more responsibility on those pairs to serve you more of the samples, or we have to think about rotation, about taking a pair connection and maintaining it for a while, but then shifting to other pairs to be able to get fresh data, different random data, to do sampling correctly. So the first gossip sub-based design, gossip sub is the protocol that pushes messages through LibP2P, was like that, where to try and rotate through subscriptions between many different pairs. Obviously, this has limitations, because rotating subscriptions is still slow, still requires you to create new connections to find pairs. And so instead, I favor less persistent connections, but there are arguments on both sides here.
On the gossip sub, how many points do we have that we per block in this construction, Donkard? How many samples per block? which is yeah.
So, okay, one more point. If you try and push this sample model into topics, then you get lots and lots of different topics if you want to properly request or distribute data. And
Subnetworks end up being very tiny, hard to find.
right, so we get many tiny, hard to find subnets. And so even though we use a solution that's maybe more stable in other situations, it might not be as stable for this problem. Then we have the alternative that we are looking into right now, where say you do sampling on a UDP-based network, and say you try and combine it with the discovery protocol to find pairs quickly within certain regions, then you do have this ability to find samples and not have this bottleneck with connections or with many different topics. And with UDP, you don't need to have this persistent connection. If you overlay it on disk V5, at some point you essentially need to have one handshake to understand each other. But then after that, once you know the pair, you can use that session to send one request message, get one response message back, and that's all of the communication. However, as we said, disk V5 has its own problems. It's more vulnerable to Sybil attacks, and we kind of want to avoid sampling from getting Sybil attacked. And yes.
And another thing, somewhere that I think there's probably very much of a hybrid that we're going to be exploring, but in terms of sending out full rows and columns, such that validators and others that want large amounts of the data are listening, that's actually a much more obvious thing to be sending probably in Gossip. But again, probably some sort of spectrum design.
Right, so you could think of rows and columns similar to shard subnets in the previous designs, where you take batches of these samples, or basically what would be a shard block, but now in this more global version of data sharding. You can take a column or you can take a row and you could assign it to a topic, and there wouldn't be this crazy amount of topics necessary, but instead you only divide it by as many rows or as many columns you have. And the messages will be larger here. Sample is very, very small. It could fit in a single network package easily. It's on the order of 500 bytes. Whereas this full column or full row is more comparable to a full shard blob. Okay, and then we need to talk about altruism. So just like serving blobs or serving beacon blocks, samples are also this type of message that peers need to serve on a network for others to be able to verify the validity of the chain. And what I'm saying here with validity, it means that peers need to verify data is available, right? Somebody needs to serve this data. The nice thing about the builder-proposer separation is that we're separating the entity that is creating the data from the entity that's collecting the fee, that is mining the data. And so we could put the responsibility for availability with the builder. The fee can be paid in advance, or can be paid in unconditionally. As long as the transaction is mined for the transaction blob, the fee is paid. Availability depends on the builder putting in the effort to publish the data. And so if everyone acts honestly, is running the sampling, attesting and adjusting fork jobs based on sampling, we can make sure that we force the builder to seed the network and to publish the data, or otherwise they wouldn't be paying a fee, right? They would be losing money here with the sunk cost essentially of paying for the data transaction but not getting the data confirmed. So
it's a highly incentivized actor, and because of the way the fee model works, is that ultimately, the risk and the cost to disseminate that data ultimately can be priced in the fee market.
Exactly. So we have good incentives for the data to be seeded, to be published. What we don't have yet is that after publishing it to the network, to retain it and to serve this larger amount of sample requests. We don't like to direct all the sample requests to this one builder endpoint, but rather like distribute the work. And then once you're distributing, you'd hit altruism problems. So think about sampling. We have like 75 samples to request per node. Basic math says that it also means that you'd have 75 samples to serve as a node if everything is distributed equally. But to distribute everything, you'll need to distribute that initial published data from the builder to all of the network. And the builder is not going to connect and reach out to every single node. So you need some altruism here, although maybe not crazy altruism, to take the data from the initial publishing towards all of the network. And then serve it to those that are also sampling. The worry here is that if validators are lazy and not participating in this sampling network as a server, that it will be very difficult to request these samples in the first place, because not everybody can contact or should contact the one builder that has the incentive to publish.
Well, it's not just validators that we're worried about being lazy. Like, you expect full nodes in general to do so.
Right, so maybe one more thing to highlight with tank sharding and data availability sampling is that this is not just a task of a validator to do sampling. Every node on the network can run the same network activity, can do the same requests. And so you don't have to stake 32 ETH to verify that the data is available somewhere on the network. You can request and make sure as a node without being staked. And this definitely creates asymmetry. Yes, yes. Okay. Right, so we need more altruism on the serving side to serve those nodes that are requesting and that are not staked. So, deadline. Sorry?
So I guess this is the problem with the networking, but how do you know who has the data? Like, is this something like IPFS or Swarm that we have to build eventually?
So I don't want to be too opinionated during this talk. I do like one design more than the other. So one solution is to try and overlay this type of sampling method on top of some type of DHT, something that's more structured to locate these samples. You can traverse a DHT by basically doing this logarithmic search to find nodes closer and closer to a certain identity. And so you could, if you are able to distribute samples towards a network that is free of symbols, that doesn't have these fake identities, then you can put them in a spot where they can easily be found.
The definition of like honesty and with respect to the altruism can be the data that you have and are expected to serve is going to be related to your public identity, such that I can make, whether it's the DHT or asking my local peers or any other sort of method, it's like I can a priori know you're supposed to have this, and then if you don't, then I can consider you, I can downscore you or consider you dishonest and maybe not go to you in the future.
Right.
I mean, how can you? I mean, maybe the guy didn't get it in the first place from the proposer, right? The data that he's supposed to deliver to another peer.
Right, so it's very difficult to attribute a file to a node that's not serving a sample, even if their identity is close to the identity of the sample. The node might not have found the sample or might not have gotten it from the builder in the first place.
I can still use it to like understand my peers and to prioritize or deprioritize peers over time. I think it's a bad thing to make a decision on a one-off, but making decisions over time I think is probably reasonable.
Right, so as with a lot of this pair scoring, over time it should average out. If that pair is consistently not serving you requests, then they are probably just lazy and you shouldn't be asking them for the sample.
The other view of that is that if they're consistently not getting it from the proposer, that's probably on them anyway, if other people are.
Right, and I mean, if they are not getting the sample from the proposer or from the builder here, then it's also really just on the builder, and then it's the correct behavior to say the data is not being available.
Even if the builder's messing with a particular node, like, you probably still don't want to ask him because the builder's messing with him.
Not useful to you. It's not about necessarily they're malicious. It's just they're not useful to you, so stop asking them.
In the back. Yep. So the consequence of data not being available is that some actor can confirm some weird commitments that maybe means other different data is available, and nobody can reconstruct the layer 2 state because we don't have access to the data anymore, but they can now claim whatever type of transition they might have wanted to introduce.
And what is the economic consequence to the actor that doesn't produce the data? Not like the network consequence. How do we enforce this?
So you mean the economic consequence to the builder here?
Like in the case, like the data's not available and I've asked a few, like how do we like root this in economic guarantees that it's
Right. So short term, it's relatively easy. You say, if you can't find the data, if it's not available, you fork away. You say, we'll follow this other chain that does have all data available. Long term, when data starts to disappear, once it's being pruned by nodes, then you start having a problem because you cannot divert anymore. Especially if you finalize, you have a problem with data availability. I mean, this is kind of an open problem. At the same time, you could try and force nodes to like at least ensure data is being published. That you at least follow a chain that at the time of publishing, we are sure that honest nodes are able to get the data. And if you have that type of guarantee, then you can at least trust that there's some honest minority that will have the data and that should be able to recover the situation. But it all depends on the parameters and how much time do you give honest nodes to retrieve this, and how many do you really need to get all this data in the first place, especially if you increase the data.
in the current system that we would have the same problem, really, if we couldn't come up with the data.
Yeah, if we, in the current system, if we somehow were going to miss a beacon block, if that would disappear, I believe something like this happened to EOS at one point. Then if one block of the chain disappears, you're not able to rerun the transition, and so new pairs will have trouble onboarding on the network.
This is kind of, you know, you can also change the bounds of what the PDP is expected to serve and change the bounds of how people are expected to join the network, and that's a conversation for tomorrow. EIP 4444. It's
pronounced EIP for force. It's written in the EIP. Joking. All right, so that's networking in a summary. I think we'll have like another later session this week about Discovery v5. This is the DHT. So if you're really motivated to work on DHTs or in sampling here, then maybe join that session. Reach out. And I think we'll close it here.
Okay, so the goal here is to go through the sessions. Whoever was the lead or ended up doing a lot of talking during that session is going to come up, and they're going to say kind of what happened, briefly, really, if there was progress made or particularly interesting next steps, or maybe noting where further collaboration on this would happen. That'd be really useful for the people that were not in the session to kind of get us all back on the same page. Tim is here. Tim, does that sound like a reasonable plan? Yeah. Okay, cool. So we're going to start with the other room, Izal, and just kind of run through them. So Does Mario or Kelvin want to tell us a quick recap on the L2 EVM usage session? Are either of you still here? Great.
Hi, there's my phone. Let's see. Kelvin said don't change the EVM when you make an L2 because it causes problems. There was a lot of talk about things that they want to do. I mean, this was mostly in the optimism context, but we talked about wanting to reserve a section of opcodes for non-use so that L2s can use them for things without fear of future addition of opcodes, then suddenly making those mean something different in the EVM. But it all is quite convoluted, because then if, say, they use that reserved section to implement something that we then do implement later, then do they have two sections of opcodes that mean it? A lot of it came down to, in building L2s, keeping things as close to how they work in L1 as possible saves a lot of headache. And then we talked about a lot of things that were not the EVM in L2s.
Thank you. We're going to stay on the L2 track, and then we'll jump into EVM, and then we'll go back, and then we'll go into sharding. So, resource pricing, storage execution, L2, L1. Anybody want to give us a recap on that? Great. There's no solution. Okay. TLDR. Spoiler alert.
Yeah, no full solution yet. But so basically, resource pricing. So I think the idea is that with this 4844, the EIP, we basically, for the first time, we have a new type of resource we want to price that is very meaningfully different from the other ones. So basically just using the existing one-dimensional gas model really has quite severe drawbacks. So if you just, give it a fixed 100,000 gas per blob price or something. So we really want to move to a multi-dimensional pricing model, and we look both at just the specific context of the EIP, so just a two-dimensional model, but then also with the context of trying to make it forward compatible with a full multi-dimensional model. And I think maybe just the TLDR was just that they are, I think, fundamentally there's a simple solution that basically works for the two-dimensional case, where basically you just have a floating, you have to just choose whether you want to have a floating gas consumption per blob, or whether you just price it in ETH directly and have that floating. So in both situations, you basically just price it separately and just try and make it as forward compatible as possible. Sorry, this probably wasn't all that helpful, but actually what then later on today, it turned out when we were talking with some of the layer 2 teams, it actually happens that the kind of layer 2 price, I don't want to kind of preemptively talk about this, but basically that there's a lot of parallels between that problem and the layer 2 pricing problems. And so that whatever solution we end up choosing for the layer 1 4844 solution can probably just be more or less copy pasted to layer 2s. So there's a lot of synergy there. So I don't know. Yeah, sorry, that was my best.
Do you have anything to add? Cool. Killed two birds with one stone there. We talked about shard data and L2 pricing today. And how to upstream L2 EVM contribution back into L1. Who was on that session and wants to talk about it? Yeah. If you think that it might be you, it's you.
Okay, so we talked about a bunch of things in this session. One of the sets of ideas was around how L2s could be a vehicle either for experimentation or with L1 features that are under serious consideration, or whether L2s could adopt new features earlier than L1s because L2s might be more agile. There were a bunch of I think it was generally agreed that it was a good thing to have more coordination and consensus built around which were the features for which this could be done, and to make sure that different L2s don't gratuitously do the same feature in different ways, try to get that kind of coordination. But we also talked about what are some of the limitations on the ability of L2s to early adopt or do experimental adoption of things. And many of those had to do with essentially the risk that an L2 gets too far out in front, either that tries something where there hasn't been enough security due diligence and something horrible goes wrong, or else that L2s adopt something out in front of Ethereum, and then Ethereum veers in the other direction, and the L2 is left either maintaining something that is no longer supported, that is never going to be adopted by Ethereum, or worse yet, where Ethereum does something that is actively inconsistent with the L2. So we talked about ways of coordinating. One of the ideas that came out was the idea of having a sort of advanced experimental version of Geth, or something like that, so that there was a set of experimental features which were coherently developed and that were designed for those who wanted to be early adopters, say an L2, to be able to adopt things in ways that were well supported and not gratuitously conflicting. Does anybody else who was there want to add? Okay.
Great. Thank you. Okay, let's do some of the EVM stuff. We have self-destruct removal and intro to EOF. Any recaps from today?
Okay, so there were actually 2 sessions about EOF. So one was supposed to be about basics and was supposed to touch the self-destruct. And the second was about the new features that are coming later. But they kind of merge into a single one. It spanned 2 hours of that. So we started with some basics, like how EOF containers works, and I tried to collect information if there is something suspicious that can be spotted in the audience. There's a recurring question if like how rigid it's supposed to be. We put like quite a lot of constraints in the spec, which some of them at least might seem confusing in the first. So you can take a look there and see if you have any comments about that. Then we moved to explaining what kind of forward compatibility EOF provides and how we can use that. And there are 2 immediate actions we can take with that. First of all, we can deprecate existing instructions safely at the time we deploy the EOF. That comes to should we remove self-destruct entirely? Should we remove other instructions like call code, maybe gas instruction, maybe PC instruction, and we have some arguments depending on the instruction if that's a good idea or like maybe it's not so, maybe there's some risk related to that. And finally, we discussed how the jumps will evolve along with the EOF. So we plan to introduce static jumps and later also functions and function calls that reside in the single EOF container. And that would be allowed to remove dynamic jumps. So there's also like quite a lot of discussion about the details about this one and like how exactly to do that, and can we move with all the features at once or like we should deploy in parts. I don't know. I think all I remember. If any other voices about that. Oh yeah, I wanted to say that. Okay, and one more topic that was kind of interesting is like, we didn't have fully specified that yet, but that's something we really want to collect feedback about is the legacy code will exist with EOF, at least for longer time. And if you can deploy the EOF from legacy code using the create, and also if you can deploy legacy code from EOF contracts. Currently that's possible, but we found some compelling arguments that deploying like legacy code from EOF is not a good idea, and we try to include that in the spec. Okay, thanks.
Thank you. Great. And Ethereum accounts. Can the Ethereum account czar come up?
So the first thing that we talked about was, should we just implement these account changes on L2? And it seems like this is something that all of the sessions touched on one way or another. It seems like the L2 sessions seem to say L1 should implement things, and the L1 sessions say L2 should implement things. It's a game of chicken. And the rough take from like core devs in the room felt like there was very rough consensus that they would like to see some of these implementations on some sort of sidechain or L2 network first. That will give them a lot more confidence as it progresses as a standard, rather than implementing something on mainnet that people don't want as much. And so that was the takeaway from that. We also asked, why aren't smart contracts popular today? And we came up with a list of some things, and I'll just read that really quickly. So security, it adds new threat model to your account over just having an EOA. It's expensive to deploy, and there's overhead for interacting with it versus just using an EOA. There's limited features in the existing smart contract wallets, and there's poor standardization around smart contract wallets in general. And we talked about maybe some solutions for the deployment issue. It might be beneficial to have some opcode that says set the code hash of an account, and that code hash could point to an already deployed contract, reducing the cost of actually deploying new code. And then last we came up with some features for accounts for smart contract wallets that we think are useful, and some exist today and some don't exist as much, and I'll read those really quickly. So obviously recovery and transaction batching are really important, and then counterfactual deployment, being able to say, I want to deploy a contract on many different networks with the same address and set up some default configuration for that account without having to actually set it up on every network. Having modularity, being able to like use new functionality for wallets without having to like manually upgrade your wallet. Spending limits, transaction sponsoring, alternative validity conditions, not being sucked into only using these ECDSA signatures. It would be good to have the ability to use quantum resistant cryptography at some point in the future, and custom nonces. And then we talked a little bit about EOA migration as well, and it didn't feel like there was strong feelings like either way, so that's something that we'll still continue discussing and try to decide, is something like EOA migration a useful thing to do in L1, or is something that we should just let it be how it is? Did anybody else from the session want to say something?
I think you sort of said this, but we talked about EOA format 1 letting us drop the gas opcode, which drops the ability to do meta transactions, which like strongly influences focusing on account abstraction, which gives us.
Is removing the gas opcode not that do meta? Doesn't the gas meta transaction come from the message from the person?
You need the gas opcode to do metering inside of the EVM, and so if we drop the gas opcode, it sort of gives us this strong incentive to like focus on account abstraction.
Account abstraction has to implement
It anyways, it like gives us this little on-ramp towards like, now we don't have this feature anymore. You can only do it in legacy. We should build it in EOA, but anyways.
Thank you. I was not a part of that room. Sounds fun. Great. We're going to move on to all the stuff that happened in here. Let's get started with the 4844 open problems. Is anybody willing to do a recap on that? I can probably do that. Let's see. So a lot of the problems that we focused on were around some of the potential attack vectors, DOS vectors, which focus either on the mempool, which there are things to work through and think through there, or just larger block dissemination in general. These are in the form of either computational resource attacks when you're sending transactions that aren't necessarily pre-validated, because you have to verify some of these commitments, and also bandwidth. You're sending around much larger things than you are today, so how can I abuse that? There are obviously places to abuse. There's also, Doncred, what was the hint that you can add?
Yeah, so one of the things was that it's currently hard to verify a mempool blob transaction. It costs like 40 to 50 milliseconds to verify the commitment. And so like by adding a Kcg, we can get that down like
Yeah, so the cost there is primarily just complexity and that being an additional thing that needs to be computed and carried around, but greatly changes the computational attack ends up being much smaller than the bandwidth, so it kind of bounds the problem to dealing with some of the bandwidth problems there. We also talked about generally just block dissemination as well, and then resource pricing was the other half of that conversation, which Ansgar did catch us up on. Were there other things that we talked about in the open problems? We spent a lot of time talking about those attacks. Was there anything else on that list at the beginning? Okay, cool. Life cycle of a blob transaction. I was not part of that session. Who wants to give us a recap of what happened over here? Great.
So with the layer 2 teams and layer 1 devs, we went through the different ways a layer 2 could adopt blob transactions to build the layer 2 chain, to basically go from initial layer 2 transaction to the output of a sequencer to a blob transaction to the memory pool and so forth through the whole system. So it was really like a good way to start the day with also introduction to the EIP. And I hope that from here, like layer 1 devs better understand the data requirements for layer 2, and layer 2 devs better understand the complexities with layer 1. And yeah, from there were more sessions about the EIP. So there was some overlap. I hope the diagrams and the conversation was useful.
Do you want to just roll into talking a bit about the implementation session and the benchmarking session?
For sure. So there were 2 more sessions focused on EIP 4844. First, one session about the implementation. The implementation really touched upon the data availability requirements, the security, and the propagation of this blob on a more technical level throughout this whole system, as well as the format of the data transaction. And again, because there were some different groups between the different sessions, we did touch on the optimization. And then later on in the next session about benchmarking and optimization, we again covered that where we do want to add that extra data, as Devconnect mentioned, and I'm not sure where if he's here, but more inputs from the Kcg rollup teams, how to optimize the blob verification, which was great. And then aside from the cryptographic optimizations, we also need to make changes to the transaction pool to better attribute bad transactions to pairs that serve them, or really that announce the transactions, regardless where you request the transaction from. If you announce it in the first place, it should not be a bad transaction. And so with this more like attributable transactions, with better verification of transactions, we discussed some improvements in how to sync and distribute these blobs. Then we all kind of like get closer to where we want to be with the EIP, to not be as afraid about the computational costs. At the same time, the bandwidth problems are still a little bit of an open problem, and we're working on that.
Thank you. Kcg Ceremony. Yeah.
Yeah. So yeah, we talked over here about the Kcg Ceremony, and if you don't know what that is, if you're familiar with Zcash, maybe you've heard of trusted setup. It's a similar idea. It's actually the exact same thing, but much, much larger. So one of the things that EIP 4844 requires is a Kcg commitment to be baked into Ethereum, the protocol. And what we need to do in advance of that is a trusted setup where we have a ton of people generate some randomness, it all gets bundled together, and then we can use the output from that ceremony to, it lets these blob transactions actually come to life. So we talked about what that would actually look like, how it would be different from other trusted setups, other ceremonies, how we can improve on it, and especially how, given this is, it's a new thing that we're adding to the protocol, how do we really build trust with the broader community? So people in Ethereum, people who don't care about Ethereum, this should be really something that has a legitimacy. So we want to make it a really large ceremony. We talked about some methods to do that using POAPs, different ways to represent their participation, how we can transfer who's running the sequencer, the coordinating server between different groups in the community, a bunch of different ways. I think those are the large topics that we covered. Ideally, we'll have this in sometime this year, but as always, timelines are iffy in Ethereum. So, hopefully this year, definitely before Shanghai, if that's when we're trying to get EIP 4844 in, and yeah. So next steps, we will be. We already have some benchmarks that have taken place. We'll be designing the UI, getting an audit of the work that's already been done. Starting to spin up multiple implementations so that people can contribute on their own in different ways, as well as starting to design what the story is, what the narrative is. Again, trying to build the community trust in understanding and having this mutual understanding that the ceremony itself is legitimate. You can trust the output, or rather that you don't have to trust it at all because of the way it's been constructed, and you can verify the transcript. So. I think that summarizes everything. Yeah, and we'll be moving forward over the next month, getting audits on these different components and starting to build awareness about getting different pockets of the community involved in the actually running the sequencer as a possibility.
Thank you. The state of the crypto libraries with respect to BLS and KZG. What's the state? Oh, I got a competition.
Yes, we looked with 2 time horizons. We've got 4844 coming, and then beyond that, the kind of full dank sharding. There are different requirements. So 4844 doesn't require much lift from where we are on the consensus side. We have this BLS 12381 library. We're all using the BLAST library. It appears to be fit for purpose and so on. So our recommendation would be that somebody fund Supranational, who create the library, to add the very small shims we need to expose the functionality to create KZG commitments and to verify openings on that. And then that's usable by the execution layer clients and also the consensus clients. So that was the easy bit. There's a much bigger lift to doing full dank sharding. So we've got things like KCG multi-proofs. We've got polynomial, all sorts of polynomial multiplication and Reed-Solomon encoding and all that kind of stuff. So the question is, where does the responsibility lie for building these components? I think our one main conclusion is that it's not reasonable to expect every client implementation team to have applied cryptography expertise. And so we need to find a way to somehow outsource this or provide the right help to client teams in order to be able to implement this stuff safely. We didn't come to any great conclusions on this, but there's some good ideas floating around. That's all I got. Mami, did you want to add? George, all right, all good. All right, we're done.